have a slide. Okay, good, great.
So you see some slides?
Mute. Unmute your computer. Yeah, just.
Okay, that better.
And full the screen.
Just your slides.
Can we close message? Yeah.
Okay.
Yes, full the screen as slideshow.
Yeah. Okay, sorry for the delay. Maybe we've got it arranged now. Pictures,
Good.
pictures, people, excellent. Okay, so this slide does answer the question that I thank Samir for valiantly attempting to do. But this has actually changed over the years. And so that gives me one of my first points is NITRC has been around since 2006. I dare to say it's one of the oldest continuously funded NIH infrastructural supports for the neuroimaging community. It started in 2006 with a mission to support the software that the neuroimaging community was generating. And at the beginning, it was called the Neuroimaging Informatics Tools and Resources Clearinghouse. So the idea to be a clearinghouse, you can go there, search for software, and again, it was sort of targeted at software so that you could find in one place, a listing of all the different softwares that did different classes of analysis. And while that was a good thing to do, there was actually an ulterior motive that the NIH had for creating such a resource. Amongst the program officers who are funding, various grants, to develop things, they kept feeling like, over the years, over the decade of the brain, the 2000s, they kept funding sort of the same thing. Samir would write a grant to do a segmentation tool, and it would be funded from 2000 to 2003. Then someone else would write a grant to let's create a segmentation tool, and they'd fund that, and that was funded from 2002 to 2005. And then in 2006, someone would write a grant. Gee, we need another segmentation tool. So there's an effort that, yes, people are getting funding, developing cool things, but they weren't really living beyond, the era of the grants. And again, the exception to this is some of the big powerhouse, tools, the SPMs and FSLs and free surfers, they kind of persisted anyway. But a lot of cool innovations being done, a lot of grants were being given to support things, but that just ended, when the grants ended and never persisted, were hard to discover, hard to kind of break into the community when the big tools, were there. So someone at the NIH decided, gee, if only we could provide a common background infrastructure, guarantee that there's a web page, a help desk, a source code repository, all this other sort of long-term infrastructure, so that fine, you go and do your cool developments on their funding, but then you could persist beyond that funding. The tool could be distributed. You don't have to do your institution to support it. The tool could have help lists and mailing lists and all that kind of infrastructure, and you yourself don't have to manage that. So it's easier for you to handle that beyond the end of the life cycle of the tool grant. And there's a chance then that tool can build a community, and if it's successful, really be grow. So that was kind of the impetus, sort of the NIH trying to ensure their investments in tools so that if many tools were emerging, you could at least find them and they could persist beyond the initial funding. So that was the origin of NITRC back in 2006, to be a clearinghouse of software resources. Fortunately, myself and our friends at Turner Consulting Group, or TCG, succeeded at getting the contract, to start that mission. And over the years, that grew from being fMRI software to including things like data. So the same infrastructure that you can use to share software, you like, a storage location, you like, help, user groups, you like email lists. The same sharing of data can really take the same infrastructure as the sharing of software. Just replace a tarball of data from your executable, and the same infrastructure and sharing mechanisms apply. So NITRC without the approval of the government, sort of moved into also data sharing, to support, that as well. And again, the big coup for NITRC came in about 2010 when the the 1,000 functional connectomes, project, had, aggregated, thousands of, resting state, data from many contributors. And they needed a place to put that for the community, to receive. Now they had, XNAT existed then, and Loris existed then, and the Lani, databases existed then. But there wasn't really a low barrier to sharing place to go that could host a large, hunk of data and really just minimize the barriers to getting that data out there. So they, fortunately turned, to NITRC, where using the same sort of file storage, systems, dumped, thousands of cases, into the NITRC archives, subdivided by, site and things like that, and really sort of launched, the low barrier to super open, data access, and really, changed the way open data sharing, could be, supported by the community and by the infrastructure. So fine, NITRC is a place to find software. NITRC is a place where you can, put data. Again, this is still a little bit of ancient history. And then the next logical step is, gee, if I can go to NITRC and find some software and download that to my own computer, I can go to NITRC and find some data and download that to my own computer. There's an alternative, to downloading everything to my own computer, and that's going to some, sort of cloud computing as well. So instead of bringing everything locally, which you can do and still do, you can also bring the software and that data to a cloud compute environment. So that was the impetus for the sort of the third leg of NITRC, which is, oops, gosh darn it, I'm sorry. The computational environment. So just trying to, oops, is that okay?
Yeah.
Okay. So instead of downloading,
Oh,
what are you
just a
doing?
second. I think you should. Did you press slideshow? Yeah, I see. This is just
Is the network done good?
this is for the platform sake. Maybe you're not for this.
Sorry about that. I could keep. Okay, so while that's the imagine, if you would, the fact that you don't have, while you can download software and can download data, you could also go to a cloud environment that has, all the same NITRC data sets shared in the first place, and has all the NITRC software shared in the first place. Then you can get into a cloud environment where, instead of downloading stuff, it's all right there and you can do the computations. So that becomes sort of the three, pillars of NITRC, that if you were seeing a screen, you see a sign that says NITRC-R, the NITRC Resources Registry. It's where you can go and find resources about, software and data and, communities. It's a place, and so that's a NITRC-R, NITRC Registry. And there's NITRC-IR, the NITRC Image Repository, which is in this case, XNAT-based database of all sorts of all the content, of the imaging content that is available. And then there's the NITRC computational environment, where you can, access, on cloud, on AWS cloud, the software of NITRC and the data of NITRC. So that you can envision that.
Do you want to share the Google slide link to me in a chat box?
Okay. Chat in the
platform.
Yeah, where's that platform?
Just on your laptop.
Yeah, the network is weak.
Is it running this?
I think.
Just
yeah.
There's a Wi-Fi there. This is hardwired, so you can
Okay.
see that it's hot. Share through that.
Yeah.
Okay.
Yeah, it's a Wi-Fi issue.
Yeah, I wondered. The crowdcast. Oh, I'm a little confused about where my crowdcast is then.
I can remove you and you join again if you
Hold on just a second. There it is. There it is.
Yeah.
So just say, post it here.
Yeah, in chat box. Yes.
Okay, so that's about
You can
where.
also sit there if you want.
No, this is okay.
It's
I'm not.
okay?
Yeah.
I can check with you and then.
Yeah. So yeah, I see it there, and so yeah. Okay.
Yeah.
Okay. So sorry about that. So fine. So I want to just introduce sort of the three main components of NITRC: the resource registry, the image repository, and the computational environment, which have built up over the years. Building upon the different types of information that NITRC has been able to host. Over the years, the scope of NITRC has advanced from purely sort of structural functional MRI in the beginning to including EEG and MEG and optical imaging and computational neuroscience and sort of clinical neuroinformatics types of resources. So what started out as fMRI, now the scope and the tools and resources and opportunities to use NITRC as a sharing platform for virtually any neuro observation type of thing has emerged. So it's been around for a long time, as I mentioned. It does not receive a heck of a lot of money. It's nice that it has persisted, and it persists exactly because it has been useful to the community. And so that's part of the reason why we're out here, advertising it and making sure people are aware of it and all the things that it can do. But it can persist because the community uses it, and so if you do use it, keep using it because that's the kind of activity that keeps it persisting. So I think that may be all I want to say as an introductory type of thing. Actually, advanced just next there. Yeah, and so there's some statistics I can share with you that I'm not going to go through them here, but there's lots of web sessions that get started, lots of users, lots of tools, lots of bandwidth stuff is coming out, data's coming out. So again, it's well used and it gets cited in the literature, a lot, so that the bang for the buck, that the NIH is getting, for this investment is actually quite high. And it's not, even though it's funded by the NIH, it is open to the world. And then again, that's an important integration of U.S. and international resources together, since it is a global community. And while much of what's there is sort of open source and free software, it is not constrained to be open source or free. Commercial stuff, everything can be there. The point of NITRC is if you're looking for something that does something, you can find it there. If you're looking for a place to put data and host data, you can host it there. If you're looking for software and data, it's the place where you can find that content. The other thing to say about hosting of content, NITRC has the underlying infrastructure to store data and to host software, but everything that NITRC holds could be a reference to somewhere else. So you don't have to commit to using NITRC as the data store or commit to using NITRC as your software development environment. You should go off and do your best practices. If it's Git, use Git. You can link your NITRC project to your Git repository, and that just expands the ability of people to find your software. They might look for it at Git, but if they look for it at NITRC, they know they can find, they can search through the content that's much more neuroimaging or neuroobservation relevant. So it provides a nice filter. Data sharing equally well, you can use NITRC's infrastructure for your data sharing, both in the sort of raw file type of format and in the image repository, or you could use your other favorite resources, OpenNeuro, Loris, anything you want. Again, you can share your data where you want, and you can connect that data sharing to your NITRC project, again, enhancing the ability for people to discover the content that you have. So again, if you're a sharer, NITRC is a good advertiser and displayer of your content in the context of the neuroimaging community. And it's a great opportunity in your grants that you write. If you have a section on trying to promote your resource, promote the things that you've done, NITRC is a great place. It's a common, location that it's a low barrier, zero cost. Share, advertise the thing you've just developed, through NITRC. It helps, get the whole community on board with, the ability, to find and use that opportunity. So we entitled this, session, sort of, how do people, use NITRC? And I could sit here and spout, things about how people use NITRC, but we invited a couple of our friends, to come and join us. I'll invite Samir up, to the table, now, to be people other than NITRC to say a little bit how, NITRC has, impacted and improved their lives.
All right, I'm going to do this without a mask. So yeah, I don't even know.
Who are you?
My name is Samir Das. I work at the Montreal Neurological Institute in Montreal, and I've been there 20 years. So I've actually seen this evolution of NITRC over all those years. And what I'm going to say is kind of a little bit of the past, present, and future. So everything David described in the past was really nice. NITRC was, there wasn't much out there at the time in terms of being able to, like there was no GitHub or any of those kind of technologies. So to be able to go and filter for whatever tool you were looking for, especially that, that was very neuroimaging focused, it was nice to have that capability. So, we started trying to include tools there over the years, and it was a very good thing that we basically promulgated it to all of the people in the neuroimaging community, and everyone I talked to was very happy to have that resource. As the years went by, it obviously evolved, and so did our interests, actually. So, I found it personally a nice place to filter all the filtering capabilities there that you can't exactly do even today with some of the other more elaborate technologies. Like if you go to GitHub, you can use, if you're very savvy as a programmer, you can filter a million things. But if you're just a non-computing user, it's really easier to actually be able to go to NITRC, see in a very simple, user-friendly way what's out there and how to filter. And so it was something that I appreciated a lot. And then, so that's kind of more like approaching the present for my experiences with NITRC. But then, of course, I come from all this from sort of an open science perspective or a reproducibility perspective or standardization. And I know there's like about a million or several, let's call it hundreds of different components to being able to properly share your data, whether starting with acquisition to getting ethics in some cases to be sharing human data, to quality control and standardization and interoperability and a million parts of that to do that successfully. And so part of the present into the future with NITRC is we've already had discussions on how to, whether, like I work on all kinds of data sharing software myself. And as much as I would like one of my tools to be the tool that everyone uses in the world, I know that's not the case. So what I find very important is to have that interoperability and connection. And something like NITRC is perfect for that because so we've been building bridges on trying to, get descriptors for high performance computing pipelines, maybe in a way that can be linked and vice versa. So even if there are other clearinghouses or if you want to link to GitHub, as David said, this is all possible and in a sort of a collaborative way with NITRC. So, you can even link to, say, Open Neuro or to the Canadian Open Neuroscience Platform or all these data sharing environments. And you could have descriptors for the tools and even some of the data on, both platforms, have them linked maybe through data lab connections, things like that. So what I like about the future is that NITRC is evolving still in that very nice user-friendly way. And it's not just about, one place, because that will never always work, but it's about collaborating with all the different, kinds of technologies, and whether it's on the data sharing side, high performance computing, or just looking for tools and descriptors of those. So for me, NITRC is a very nice positive, and I encourage you to go and check it out. I think you'll be happy when you do.
Great.
Cool.
Thank you. Yep. So Samir represented the old school. I'm also going to call up Nazak now to represent the next generation of folks who also are trying to find NITRC useful. So now if you switch to that other slide I sent you in the thing. we'll hear another view of the using of NITRC.
It's animated, so we're gonna
Just a second.
go through it if that's
Yeah.
possible.
Do you want to use this?
Sure.
Just use iPad.
Awesome.
Oh, and I guess I'll let you introduce yourself as well. So.
Yeah, absolutely. All right. Hello, everyone. My name is Nazik, and I am a graduate student at the University of California, Irvine, studying aging and Down syndrome. So just a little background of my project and why I chose NITRC as a repository to save my data in. So individuals with Down syndrome are at a higher risk of developing Alzheimer's disease due to the triplication of their chromosome 21, which make them express beta amyloid in their brain. And because of that, we use a lot of PET imaging to assess regional amyloid in their brain. And when you're working with PET imaging, you would need a structural T1 scan to kind of identify the regional boundaries of different regions of interest in the brain. And collecting MRI scans in individuals with Down syndrome is extremely hard due to motion artifacts. So we actually end up excluding a lot of participants in our study. All of this motivated us to create an MRI-based Down syndrome brain atlas for the use of amyloid and tau assessment in the brain in the Down syndrome population. So when researchers do not have a Down syndrome brain atlas, what they typically end up using is a healthy individual brain scan, T1 scan, that's typically vastly different from the brain morphometry of individuals with Down syndrome. So you can see how there is a huge need for a Down syndrome brain atlas in the field. So for this reason, it was important for us to make this Down syndrome brain atlas as publicly available as possible and to just be accessible by all researchers in the field. So we actually wrote a paper about this atlas, and I just included a screenshot here if you're interested in taking a look at it. But as I mentioned, we chose to use NITRC to upload our brain atlas, and NITRC actually allowed us to include a brief description of our atlas in the repository and kind of manage the brain atlas, have a discussion around it with other scientists, and it also allow us to just make it just more accessible and allow us to see how many people downloaded the atlas, for example, and tag new releases if we have new releases, and so on and so forth. So yeah, that's my experience with NITRC.
Great, thank you.
Thank you so much for listening.
And did you find the barriers to sharing were acceptable?
Yes, for sure.
Is there anything about it that could be improved to make other people more able to use the resource?
When I first started using NITRC, it was just a little hard for me accessing the resources and how to get started. But then as soon as I was directed to NITRC-R, I was able to find more resources and I was able to start a new project doing that.
Great.
All right. Thank you.
So that helps, and again, Samir brought up the idea of, really trying to promote open science better. NITRC is, again, amongst the many platforms available to you when you write your paper. If sharing data is an issue, NITRC is amongst the places where you can share data. What I'm going to do next is if I could just use a web browser.
Okay.
Oh,
You mean,
I'll just, yeah.
yeah.
And I'll do that in just a second. If you are writing software, NITRC, fine, do it in GitHub, that's great. But you can advertise that software even, more so by including that in a NITRC, project. If you're generating results, you should share that data somewhere. If you're not sharing it somewhere else, you can share it, through the NITRC resources. If you're generating statistical notebooks and things like that, share it where you want. But again, you can create a NITRC project for your paper that accumulates all these different elements together for wherever they live, so those all can be cleared through a NITRC project to support your particular image, like they can do through GitHub and things like that. But again, NITRC just gives another way to promote that. So the last thing I wanted to do is a quick little demo. I guess I have to, sorry about that, chasing you around. Two things that I want to show. One of which is another, what would be a user story, except they aren't able to be here. And again, always dangerous to do things live. And it's a project called, so if you know a project, you can find it at NITRC, and this is NeuroStack. Spell. So NeuroStack is a new project, again, developed by another graduate student who is working on building AWS infrastructures. So this helps leverage the ability for NITRC to manage computation environments in AWS, and lets you build up the uses all the pre-installed software of NITRC to be able to build up dynamic clusters and build a scale to do large scale computation in the cloud using their specifications. So they've done a bunch of testing of common things, FreeSurfer, FSL, AFNI, and the timings for doing large data sets and small data sets, and really gives you the ability to sort of price out what the cloud versus non-cloud operations would be for specific studies. So again, it's an example of the community using the infrastructure of NITRC to be able to provide generalized solutions to particular computational problems, and give you a comparison and contrasting of how that might cost if you were to do it in the cloud. So it helps you sort of understand that if that's the right solution that you might be interested in. The other snippet I want to show before turning things over to the rest of you to ask questions is a new resource we've beginning to prototype, or to begin, this is the beta release of that. And that is, let me first get there and I'll talk, because I can't do two things at once. NITRC is nice, especially in the old days when there's only a few pieces of software that do any particular thing. In the old days, if you were looking for segmentation software, you could type segmentation in there and you'd get 3 or 4 answers, and fine, you'd pick between those 3 or 4 answers. Right now, if I were to search for segmentation, you'd find about 100 tools that are doing some sort of segmentation. So what's a poor researcher to do when faced with that blessing of many options? Well, eventually you need to make a decision. Why am I going to try some set of software? NITRC helps you understand sort of the popularity and some of the use factors for a given piece of software. Now, in this case, I'm picking on one of the most famous and popular software tools known to humankind, but FreeSurfer, it has 7,500 publications that have used that, so that's very good evidence. It has been downloaded from NITRC. Oops. Somewhere on here, there's a download count, and of course, it's FreeSurfer, so it's a large number. So that's good, and that shows that it's popular. But popularity is not always the same as quality. So the new functionality that we're beginning to roll out in various domains is this little functionality called performance data. So in specific topics, in this case, the topic of subcortical segmentation, we're beginning to take more and more of the tools that claim to do that function and be able to sort of run them head to head and generate some sort of background, independent statistics about the operation of these different tools. So in this case, just an example, FreeSurfer, in some sort of known data sets where humans have done the segmentation, so we can compare the automated versus human segmentation accuracy across different structures, across different volumes and different things. And it also compares across free surfer compared to all the other tools that claim to do that type of functionality. So this is a way to help evaluate a particular tool in relative to the constellation of other tools that do similar things, and again could be a valuable resource to helping decide what tool that you want to use. There are other considerations about what tool to pick, one of which is how long do they take to process. Free surface kind of long. Another is on what computational platforms do they operate, and things like that. Of course, it's nice that NITRC as a sort of neutral broker is providing this information, so we can't necessarily stack it in favor or in favor of anyone in particular. But quite frankly, different tools do perform better or worse in different situations. So this is an evolving system. So if you were the person who developed that tool that's your sort of lowest there, well, you may say, wait, our tool does much better when it's wiggly kids or something. So we can evolve the stack of test batteries that we do and expand that to support the needs and desires of the community in terms of making sure that each tool has an opportunity to be shown in its best light, but we can still sort of aggregate that information across how all the tools perform on common data analysis. So that's kind of the newest, coolest thing we're beginning to play out here. We're clearly open for information and feedback on this particular system. We think it's important to be able to rate and rank and do performance testing on the various tools. But again, how we do that, how we deliver that information to the community really needs to be driven by the community. What tools should be in that test? What testing should we be doing? What other domains should be added to this kind of testing is really up to the community to help guide us on. So I think that's the types of things I wanted to talk about and share with you to make sure you're all energized and supportive of the NITRC community, because it needs to continue to be used so that the NIH can continue to fund it in support of your works. So thank you very much. Questions? Yes.
I was wondering, how do you see the synergy of NITRC and platforms like GitHub?
So GitHub is often where people will do their development, and that's great. GitHub is not the best place, in my opinion, to search for all the things that do a particular type of analysis. So our sort of evolution is that you, the community, develop wherever you're happiest. In the old days, you might have done it on SourceForge or GForge on NITRC. Nowadays, that's almost all out in GitHub. So a NITRC project links very seamlessly to a GitHub account. All of the NITRC content, the help pages, the websites, and all of that sort of automatically can be populated by your GitHub account. So NITRC is really just in the worst case, another advertisement for your project on GitHub. But it has some benefits in that there's a standardization of the information that's presented, exactly on a NITRC homepage, where on a NITRC project page, where the homepage is, where the help is, where other things are, which is also similar, sort of standardized in GitHub. But this is standard regardless of it came from GitHub or somewhere else. The NITRC layout page is very comfortable and common, and it just makes sure that the searching and filtering is kind of neuroimaging, neuroobservation, sort of centric. So it helps coalesce the gobs of information that are out on GitHub. And by the time you put it into a NITRC project, it might be a little bit more mature than the random stuff you might be working on, in the GitHub side of things. So it's a filter, it's an advertisement, sort of layer on top of what you want to do in GitHub anyway. Yes.
But updating, like how does that work?
So the updating is relatively easy when you're doing GitHub, since it's a link to whatever your GitHub page is. You update something on GitHub, the NITRC forum link, for example, is just a link to your forum or your issues or whatever, so it stays in line with your issues. When you don't use an outside resource, like GitHub, and you do do things within your own project at NITRC, then it's really up to the developer to make sure things stay up to date. If you have a latest release announcement on the NITRC page, and you created the project 10 years ago and never come back and update that, well, then it can get out of sync. So when it can be connected to something you are dynamically updating, that's better. If you don't do that, we highly request that our administrators of the pages keep things up to date. and, rely on the community that if you run into something that's, a little outdated, well, poke, the administrator of that project, or poke us to poke the administrators. And again, it's very collaborative, very helpful community. We serve, what the community needs, and we help, to get tools listed and to, encourage administrators to sort of do the right thing. So again, if anything's out of date, let us know, and we try to help you keep it up to date and, poke out of date content.
And there's one question in
Yeah.
chat. Could you please repeat? Why doesn't NITRC CE support MATLAB allow me to run MATLAB IDE when I provide my own license? Are there any plans to allow it in the future? This is a big limiting factor.
So MATLAB and the computational environment. So the current sort of old school solution is to use the MATLAB runtime compiled, situations where, yes, we don't necessarily have the way to authorize MATLAB on the computational environments, but using the runtime compiled versions, that was sort of our workaround. I'm guessing by the nature of that question, MATLAB IDE may be a way for a user to authenticate themselves on the CE instance, and that's a great question. We should support that if that's easily supportable. And thank you, and we will take note of that and try to support that in the future. I hope maybe that was recent development, and therefore we just haven't gotten to that yet. And thank you for the community to ask that. That's the kind of evolution we'd like to do. So
Yeah, that's it. There is another
Okay,
question
question there.
in audience.
There's a follow-up question. Second class, is there an easy way to sync between GitHub code and NITRC?
yeah, my answer to that's going to be sort of the automatically syncs, because it's only the link. So
There's no function where you every time you update that it will recognize and sync between GitHub.
like if you update the description or something with the description in NITRC, update. Right now, there isn't anything more than just where the linkage is between the two systems are. It's a work in progress to try to be a little bit more dynamic, to have some sort of YAML, file, some sort of description file that you maintain on your GitHub account, and that the content of that YAML file would be able to go and propagate more specific information into the NITRC registry. So that's something we're working on to try to increase the level of interoperation between the NITRC page and your GitHub account. And the good example of that is version number. And if there's the free surfer page there or whatever, the tool page there, you might have written that it's version 7. If on GitHub, and if you statically do that, even though your link to the releases goes to version 8, if you wrote version 7 in the hard-coded thing, then it still looks like version 7 until you update that. But if we can so you would get to, if you go to the download, you would actually get to the version 8 that you mean for people to get at GitHub, but the documentation on NITRC would be out of date. So yes, soon, I'm not quite sure the time frame of the update, but getting a more precise YAML file that you then keep on GitHub that propagates back is in our plans.
And is it a JavaScript-based upload of code, or is it something where there's a similar device as in GitHub where you can actually sync with a local drive folder that you have specifically assigned to that project that you created?
Sorry, David. Maybe you should just repeat the
Oh, yeah.
question for the online audience.
Yeah. So the question is it JavaScript, or how is sort of the syncing done, of the content, from the GitHub to NITRC? And again, most of or did I misinterpret the question?
No, I guess your answer to that was there wasn't really meant, okay, so there's no sort of seamless sort of integration of synchronization between GitHub and NITRC. But when you are like in GitHub, you can assign a local folder on the local machine and you sync that with GitHub. So every time you change anything in that folder, you send a command and it'll sync with GitHub. Is there something similar with NITRC, or is it only based on, I don't know, a browser or JavaScript interface where you say, okay, upload this file?
Okay. So I think the question is about syncing, local changes between Git GitHub, your local machine, GitHub, and NITRC. And at the moment, it's really just the shared, links to the GitHub being the common place, so that the NITRC project links to the GitHub content, via HTTP. Really, there's not really any JavaScript or copying of content from GitHub to the project, but really just pointers from the NITRC page to the GitHub content. So if there's more to that, we can discuss it. Okay, yeah.
It's about collaboration. So is there a way to like share data between collaborators on the trip, but only accessible between collaborators?
So the question is about, is there a way to share content, share data between just a specific set of collaborators as opposed to the whole world? And the answer is yes. So each element of the file release system, of the data sharing system, is controllable in terms of its access. Each NITRC project can have a set of members, and so if you wanted a particular group in your data sharing, you can only sharing only to members, and you can control who's on the membership list, and that way the authentication of accessing any of that content would only be to the members of that list. So you can control if it's a nobody can see it, if only members or certain types of members can see it, or if the whole world can see it. So that's at the project level, and that's actually probably even at the data release level, where you have that full control over that. So it hopefully solves that kind of problem easily.
There is no question in chat. Is there any other question in audience? Okay.
And NITRC is here at booth 22 and is always happy to talk to people and work through specific problems, or you can find me or whatever. We're out there.
Join me for.
Good.